viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arabic College, University of Delhi. So presently we are going through our series of database management system, and the topic which we are going through currently is about the query processing and optimization. In the previous lectures we have seen what actually query processing is. So basically we can say in a nutshell that it is actually a group of activities which are required in order to execute a query. What kind of activities I am talking about here is actually parsing the particular query which is to be executed, then generating the kind of we can say parse tree out of it, then an optimization plan, or the best plan has to be executed, and in between it is also needed to be converted into the low level format kind of let's say relational algebra expressions in order to be get executed from our through our system. And then finally in order to optimize it, we need to select one particular plan which, or the system needs to select one particular plan which is actually we can say is the best in terms of cost. So now when we talk about this cost of the query, there comes a concept of optimization, and in this optimization, as the term indicates, that if we want to optimize the query, we need to see various plans through which it can be executed, what will be the cost of different plans, and then we the system will select the one which is kind of we can say the least expensive. Now the point here is how is this query cost is going to be estimated, how this query cost is going to be calculated, what all factors will be included while we estimate the query cost. So basically if we talk about estimating query cost specifically, we have seen in our previous lectures that there can be multiple plans for a query and we need to choose the best one among them, and it can be done obviously by comparing each possible plan in terms of their estimated cost. Now cost include in terms of various resources. The cost will be calculated for various resources which are we can see which are to be used while execution of that query. So if we think in detail that what all resources will be required when we when we are going to execute a query. So execution of a query is all about accessing some particular information, then it could follow by insertion or deletion operation. So first of all, in order to access the information, we need to access the disk. So that is basically a hard disk I am talking about, where your database is actually stored. So there will be some number of disk accesses which are involved. Then this is one of the resources. Then another resources is something which is very trivial, we can say, is CPU time, because execution time will be taken by CPU to execute a query. So CPU time obviously here is a resource, and and in another scenario, if I am not talking about centralized system, that means the system is actually a parallel database system or it is a distributed system, then I am also talking about the communication cost. So number of disk accesses, that means when the disk is going to be accessed, what cost is going to be included into that. Then what is the execution time taken by the CPU to execute a query, and then the cost of communication if the system is not centralized. So all these can be taken as various resources, and in order to estimate the cost of a query evaluation plan, we need to use the number of blocks transferred from the disk and the number of disk seeks. So here obviously I am talking about the first parameter which we have seen, which is about the number of disk access. So in order to estimate this disk access, there will be if we see at the low level detail, there will be some blocks of the data which are to be transferred from the disk, and there will be number of some disk seeks which are there in order to locate that particular block which is to be transferred. Now, assuming here let us do a very simple calculation. Assuming our disk is having an average block access time of Ts second, where S we will write in kind of subscript. So, average block access time of Ts seconds our disk is having, and it is going to take an average of T subscript T seconds to transfer X data blocks, where X is the number of data blocks. So, it is going to take, let us say T subscript T seconds to transfer some X data blocks. Now, if we talk about block access time, this block access time is going to be the sum of the disk access time and its rotational latency. So, rotational latency we also need to take care of, and the sum of disk seek time, both the factors will together count in the block access time. So, for example, if your system is performing let us say S number of seeks, then the time taken for the total operation will be B into T of T plus S into T of S. Now, let us try to understand this thing. So, T of S and T of T, I have already told you that these are basically average second to transfer X data blocks, that is T of T, and average block access time is T of S, and S number of seeks are being performed. So, capital S will be multiplied by T of T, and what is here B? So, B is actually the number of blocks which is going to be we can say performed, which is going to be transferred. So, here let us assume that T of T is equals to 0.1 millisecond and T of S is equals to 4 millisecond. Block size, let us say that's 4 KB, and the transfer rate is 40 MB per second. So, with this simple calculation, if we calculate the estimated cost of the given query evaluation plan, if we talk about number of disk access, here I have not taken CPU execution time into consideration, and neither I have gone through the parallel and distributed database systems. Those two factors I have not counted here. We are just focusing on the disk access time, and disk access time will be calculated with the help of these simple calculations. So, also one important factor is when we talk about the disk access. So, is it actually always the scenario that your data is coming from the disk? No, your data can be in random access memory also, but the user assume that initially the data is read from the disk only. There are some chances that the information is already present in the main memory. Then in that situation, your we can say the cost of execution comes out significantly less than the estimated value. But why we are kind of going with that disk access calculation every time? Because we can say that the estimating the cost will be we will be considering the worst case that could happen. If the time which is going to be taken is lesser than the estimated value, then it is a win-win situation for the system, for the user also. But initially let us assume that data is there present in the disk only, and we will be calculating the number of disk access or the cost of disk access, we can say. There will be, apart from this, there will be other aspects of optimization. Now, what other aspects of optimization I am talking about is, one is the response time. Now, what is the response time? Response time is the time required to execute the plan. Now, that could be used for estimating the cost of query evaluation plan. Yes, that is one of the factors which is to be kind of taken into consideration when we are talking about the cost estimation of a query evaluation plan, that is nothing but the response time, that is the time required to execute the plan. But unless we know about the query evaluation plan, it is difficult to calculate the response time. Now, why it is difficult to calculate the response time? Because when the query begins, its execution and the response time become dependent on the contents stored in the buffer. But what all contents are stored in the buffer and what all contents are absent from the buffer scenario will be required, some disk access, how many disk access are required, that we can see. But whether the contents are stored in the buffer initially or not, that information is actually we can say difficult to retrieve. So, in that situation it is the response time is actually dependent on the contents stored in the buffer, and it is difficult to calculate the response time without actually executing the query evaluation plan, because on executing the query evaluation plan we will be able to know what contents are or the system will be able to know, we can say, what contents are taken from the buffer, what contents are taken from the disk, and so on and so forth. Now, for example, we have one another aspect of this disk access or buffer access, which we can see is we have heard, and it is a very common scenario, that our system is having not one single hard disk but the multiple disk. So, when a system with a multiple disk is present, the response time will depends on what way these accesses are distributed among the disk, which particular disk is to be accessed and when. So, there is completely a different scenario when we talk about a system with having multiple disks. So, it is difficult to estimate without having detailed knowledge of the data layout present over the disk. Now, again this is we can say it is a very low level detail. If we have multiple disks, that means we need to have the whole layout of the data storage, that what particular data is stored in which particular disk, and for the query execution, let us say we consider a particular query, which relations are to be we can say accessed, and what in which of the disk those relations are to be stored, those relations are actually stored. So, that means in order to estimate this estimate the response time in case of a multiple disk presence, it is actually difficult without having detailed knowledge of overall data layout, or we can say overall data structure present over the disk. So, basically till this point what we have seen, that what actually our query processing is, we have started from giving a simple definition of the query processing, then how we are going to estimate the query cost, that we have seen, what all factors will be included in case of estimation of the query cost, and we have seen in detail the calculation of disk access cost. And apart from disk access cost, we are going through other aspects of optimization. One which is very important is about the response time, and response time will be different in case of the single disk, while the response time is going to be very different in case of multiple disks are present. And in order to estimate where multiple disks are present, in order to estimate the response time, we need to have a detailed knowledge of the data layout present over the disk. So, basically we can say after all these incidences, or after all these situations that we have gone through, we can say consequently instead of minimizing the response time for any query evaluation plan, the optimizer finds it better to reduce the total resource consumption of the query plan, because the job of the optimizer is to optimize the cost. So, rather than minimizing the response time, which is difficult to calculate in different scenarios, it is a better strategy for the optimizer that to reduce the total resource consumption of the query plan rather than chasing the response time thing. So, thus to estimate the cost of a query evaluation plan, what is the focus, or we can say what is the agenda? The focus is to minimize the resources used for accessing the disk or use of the extra resources. That is something which is actually we need to minimize in order to estimate the cost of a query evaluation plan. Now we are looking into various aspects of the query evaluation plan, or we can say the optimization of queries. One important aspect of the optimization occurs at relational algebra level. Now, please recall that when we were talking about the query processing, one important step after parsing was the translation of queries into relational algebra expressions. And why this is required? Because our queries are actually written into some high level database languages like SQL, that is very easy for a human being to read and write, or to we can say write a query in the SQL. But as far as your system is concerned, system is not comfortable with SQL because that is a high level database language, while while your system is going to convert that SQL into relational algebra. So, that is a very important point, and cost one aspect of optimization occurs at that particular level also, when your system is attempting to find an expression that is equivalent to the given expression but more efficient to execute. So, what I am trying to say here is, corresponding to one particular SQL query, there can be many relational algebra expressions which are going to yield the same result, but the different relational algebra expressions will be different in terms of efficiency, in terms of cost, I can say. So, one aspect of optimization which is very important is, that is at the relational algebra level, when the system is translating, when the system is trying for that translation, we need to have an expression of the relational algebra which is equivalent to the given expression of the SQL, but more efficient to execute. So, we have seen different aspects. One is at the runtime. We can say one is about the response time, which is actually, we can say difficult to execute for a number of difficult to estimate for a number of reasons, and hence rather than chasing the response time thing, it is better for an optimizer to focus on the reduction of the usage of the various resources. Another aspect of optimization was the at the relational algebra level, when the system is attempting to find an equivalent we can say equivalent expression of the given SQL query. Apart from these two, we have another aspect is actually which focuses on selecting a detailed strategy for processing the query. For example, choosing an algorithm to use for executing an operation, and choosing the specific indices to use, and so on, and there can be various others. So, that is also kind of, we can say, selection of a detailed strategy for processing the query is also very important point when we talk about the various aspects of query optimizations, because choosing various algorithm for executing an operation, or choosing the different specific indices is definitely going to create a difference. Now we have seen till this point, we have seen the query optimization and query processing, both the activities in what we can say in a detailed manner. So so the first question, or one question which comes up in the mind is it actually kind of worth spending that much of time on to your we can say query optimization? Is it actually going to pay the system a lot, because we as maybe database application designers, or we as database administrator, we are focusing we are focusing much on the query optimization. So is it is it worth that much? That is something which is worth thinking for. So basically, if we go into much more details of this particular topic, we will be able to notice that the difference in the cost in terms of evaluation time and other resources I am talking about, between a good strategy and a bad strategy is often substantial, and maybe several orders of magnitude. So when we say several orders of magnitude, that means this is something worth spending time, and kind of worth spending time on, or worth researching further, because it is going to give us a different it is going to give us, we can say, a huge difference in terms of cost, in terms of evaluation time. If we are going to choose a good strategy, or we are going to choose a bad strategy, the difference between the executions time or the evaluation times is going to be very significant. So yes, query optimization is something which we should research, which we should study upon. So let me summarize this lecture. In this particular lecture, what we have started with is actually what is optimization, and then we have seen how to evaluate or how to estimate the query cost, what are the factors of estimation, and we have seen various factors, out of which we have seen the number of disk access in the detail, and then we have gone through other aspects of optimization, which is the translation at the relational algebra level, dealing with response time, we can say, then we can say all dealing with the response time, then selection of the detailed strategy for processing the query, and then we have seen that yes, there is a substantial difference between a good strategy of query processing and a bad strategy, which is going to offer several orders of magnitude in terms of a good response time. So yes, we can say we should focus on the query optimization. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed this particular lecture. I will continue in the next one with the new topic of transaction management. Till then, take care. Goodbye.